Hello, and hope you are doing well. My name is Lamarcus, and today, on behalf of Aim Ahead, I will be showing you how to perform a Pearson's correlation using RStudio. We will utilize the MEPS database. The Pearson's correlation is used to determine if there is a linear association between two continuous variables. This is another analysis that assumes both variables have a normal distribution. We will first provide an overview of the Pearson's correlation. Next, we'll demonstrate how to tidy our MEPS data so that we may carry out the Pearson's correlation. After this, we'll demonstrate how to visualize the normality of the variables. Finally, we will show you how to execute a Pearson's correlation. The Pearson's correlation is used to evaluate the strength or the magnitude of the linear relationship between two variables that must be continuous in nature. This is considered to be a parametric test because the distribution of each variable should fit the bell or the normal curve. Again, we emphasize that relationship should be a linear relationship. If these assumptions are violated, you can consider other types of correlation analyses, which we will go over in another module. So to reiterate, the values from both variables should fit the normal distribution. In addition, it is important to note that extreme outliers can affect the results derived from a Pearson's correlation. On the other hand, other types of correlation analyses are not affected by outliers as much. In this example, our first variable is body mass index, which is a standardized measure of a person's weight while also accounting for their height. Values above 30 are considered obese. The second variable in this example is a respondent's self-reported age. As usual, we present our research question. The question is as follows. Is there an association between BMI and age among adults within the United States? As always, we have provided the script for this exercise so that you can follow along. Many of the packages in this session may be familiar to you by now. These include the Haven, DevTools, and MEPS packages to import MEPS data. Remember, if you have not installed these packages, you will need to do so first before you can load them with the library command. We can import the MEPS data in our session using the read MEPS function. We can specify the year with the year equals command and select the type of data file with a type equals command. In this example, we use a full-year consolidated data file. The full-year consolidated data file has quite a bit of demographic information like education level, marital status, and some health information as well, such as self-reported hypertension and diabetes. In this example, we will use self-reported BMI and age. We use the select function in order to keep only the variables that we will be utilizing for this specific analysis. This is a very simple step that we have used before. We can use the summary command to obtain basic information about both variables since they are continuous in nature. When we examine the values for BMI and age, we notice that there are negative values for BMI, which does not seem to make sense. When we look at the code book, we realize that these do not correspond to values that were provided by respondents, but instead they represent sort of missing responses or situations where it's inapplicable due to perhaps a person's age. We apply a filter to remove the negative values from the BMI. When we perform a summary of the filter data set, we are able to see that all of the negative values for BMI have been removed. We now conduct a histogram to evaluate the distribution of BMI. It appears to somewhat approximate a normal distribution, but it is a little bit skewed to the right. For the purpose of this example, we will proceed with the rest of the analysis. You should also note that we produce a histogram for the variable corresponding to age as well. For our next step, we demonstrate how to conduct the Pearson's correlation test between age and BMI. This step makes use of the core test function. After running the test, we see that the correlation coefficient is 0.153 and the p-value is less than 0.001. This means that there is a direct relationship between the age and BMI. As a person ages, their BMI tends to increase. The correlation coefficient can range between -1 to 1. A value of 1 indicates a perfect linear relationship where every increase in one variable is always accompanied by an increase in the other variable. Correspondingly, a value of -1 lets us know that an increase in one variable is always associated with a decrease in the other variable. So let's summarize what we've learned. The Pearson's correlation is used to evaluate the strength of a linear relationship between two continuous variables. One criteria that we have to evaluate is the normality for both of the variables that we intend to include within the analysis. And finally, the values of the resulting correlation coefficient range from -1 to +1, and values which are closer to 1 indicate a stronger relationship, or values which are closer to an absolute value of 1 indicate a stronger relationship. Well, that's all we have for this session. We hope that this quick session provided you with a good start on how to conduct a Pearson's correlation within RStudio. Of course, you can learn even more with the hands-on practice that we have in Codio. So be sure to review those modules. Thank you so much.